If I were to say to you, 2 to what power gives me 8, you should be able to tell me that that would be cubed. 2 cubed gives me 8, so 2 times 2 times 2 gives me 8. If I were to say to you, 3 to what power gives me 9, you'd be able to tell me that that's 3 squared. A little more difficult one, if I were to tell you 2 to what power gives me 1/4, well, I know that 1/4 is 2 squared, right? But don't forget, in order to get 2 squared from the numerator to denominator, all I have to do is make it negative. So that would give me 2 to the negative 2. Okay, those are easy. What if I were to tell you 2 to what power gives me 15? Well, we all know that there's no way that that's an easy number to figure out. 2 to any power is not going to give me an odd number, but there has to be some number that I can put in for x that will give me 15. This is the reason that logarithms were developed. And you'll see in a while how we can figure out 2 to what power is going to give me 15. And obviously, if I know that 2 cubed is 8 and 2 to the 4th is 16, then the number is going to be somewhere between 3 and 4. So 2 to some number between 3 and 4 is going to give me 15. And as a matter of fact, it's going to be even closer to 4, but it's going to be an irrational number. So herein lies the basic reason that logarithms were found. We need a way to be able to figure out what that number is exactly. And logarithms do that trick. But the first thing you have to figure out is how to switch between a logarithm and an exponent, or from an exponent to a logarithm. So the first thing we need to learn is how to read this statement right here. This is log base b of y equals x, just like it says here. Log base b of y equals x. Okay? Remember, when we're reading exponents, this is base of b to the x equals y. Notice in both cases, b stands for the base. This is going to be very helpful when we're converting from logarithmic functions to exponential functions. So how do we do this? Here is the statement that explains to you how. Log base b of y equals x if and only if base of b to the x equals y. If you remember if and only if from geometry, it means that this is true only if this is true, but I can also read it backwards. This is true only if this is true. Okay, so this is called logarithmic form, and this is called exponential form. When I'm converting from logarithms to exponents and exponents back to logarithms, I just call it, let's do the swirly. The swirly starts with the base. I'm going to cross over the equal sign, and I'm going to come back right after the base. That's the swirly. So notice if I do that, change this from logs to exponents, I'm going to get base of b to the x equals y. The swirly also works when turning exponents to logarithms. Start with the base, cross the equal sign, come back to right after the base. And if I were to take this and convert it to a logarithm, it would be log base b of y equals x. Notice I end up with this. Let's see how that works. So what we want to do first is we want to try some of these. I want to take numbers 1, 2, and 3 and change them from logarithmic form into exponential form. So I'm going to take this log and I want to change it into an exponent. So what I'm going to do is, I like the swirly. I know that whatever the base of the log in becomes the base of my exponential. So 3 is going to be the first number. I'm going to come across the equal sign to 4 and back to 81. So when I come across the equal sign, I'm going to have 3 to the 4th equals 81. 3 to the 4th equals 81. Now let's do this next one. I'm going to start with the base. The base of the logarithm becomes the base of my exponent. I'm going to cross over here to the 1, and I'm going to come back to the 7. Now, is this a true statement? 7 to the 1st equals 7? Of course that's true. Now let's skip down to number 4, and let's change from exponential form to logarithmic form. Don't forget, the base of the exponent becomes the base of my log. So the first thing I'm going to do, since I'm going from exponential to logs, is I'm going to write the word log. And I know the base of this exponent is 2, so that becomes the base of my log. And now I'm going to do the same thing. I'm going to cross across the equal sign and come back in front of the base. So log base 2 of 8 equals 3. And I'm going to write it like this. Log base 2 of 8 equals 3. Let's try this one right here. Let's change this back into logs. So remember, the first thing if I'm converting to logs is I'm going to write the word log, and the base of that exponent is the base of my log. So this is the base of my exponent, so it's going to be the base of my log. I'm going to cross across the equal sign, so log base 1/4 of 4 equals -1. So for this lesson, number 7 to 12 are probably the hardest problems. They want you to evaluate this. In other words, they want you to find out what this equals, and without using a calculator. So I'm just going to set it equal to y. So if I'm in logs and I want to figure out what this equals, I want to basically do the swirly. I'm going to change it to exponents. So the base of the log is 9, so that's 9. 9 to the y equals 1. Okay, 9, cross over the equal sign to the y equals 1. Notice I went from log to exponents. And now I have to ask myself, what does y have to be? 9 to what power is going to give me 1? And if you remember, anything to the 0 power gives me 1. Let's try number 8. Again, I want to know what this evaluates at. What does it equal? And I'm just going to set it equal to y. And we're going to say the base of that log becomes the base of my exponent. Cross over the equal sign, equals, come back in front of the base. So this is in logs. I'm going to change it to exponents. The base of that log becomes the base of my exponent. 11 to the y equals 21. Well, 11 to what power equals 121? Y is going to have to be 2. Let's look at 10. Wow, this is a fraction. So I'm still trying to figure out what this equals. The base of my log becomes the base of my exponent. To what power equals 1 over 64. So 4 to what power equals 1 over 64? Well, I know that 4 cubed gives me 64, and if you remember from the previous slide, how do I get something from a numerator to a denominator? I make it negative. So 4 to the -3rd is going to give me 1 over 64. So y is going to equal -3. Let's try this one. 2 to what power equals 1 over 16? So 2 log base 2 becomes my base of my exponent. 2 to what power gives me 1 over 16? And again, I know it's going to have to be a negative number because I need to get it into the denominator. 2 squared is 4. 2 cubed is 8, which means that 2 to the 4th is 16. And if I make it 2 to the -4th, remember, I'm not allowed to have negative exponents. That's going to make it 1 over 2 to the 4th, which is 1 over 16. So my work would check. There are going to be two weird looking things that you see, and we're just going to give them names. A common logarithm has a base of 10. So I don't have to write log base 10. I can just write log. If you see something with a plain old log, it assumes there's a 10 in there. I think it's a good habit to write a 10 in there so that I have a base every time. It makes it easier to go to exponents. The other one is called a natural logarithm. That has a base of e. Remember, we did e the past couple days. That means log base e, or I call it ln. So a lot of times I will actually take these and log base 10 of 12 and rewrite it, just in case I'm trying to go to exponents. You don't have to. Remember, ln is log base e of 3. Now, these we're evaluating, but we're using a calculator this time because there is no way I can figure out 10 to what power equals 12. Well, I know 10 to the first is 10, 10 to the second is 100, so 10 to what power gives me 12, I have no idea. So I'm going to use my calculator for this. And on your calculator, you'll notice you have two buttons. The log button is right there, and the ln button is right there. And don't forget, plain old log button right there stands for this, log with a base of 10. ln button right there stands for log with a base of e. And you notice if I type log 12 in, I get this irrational number. And if I type ln 3 in, I get this irrational number. We're always going to round to 3 decimals. So remember, when rounding to 3 decimals, I want to look at the fourth. If it's less than 5, I just truncate it right there. So the answer here would be 1.079. I'm going to look at ln of 3. I'm going to go to the fourth decimal, which is a 6, which will bring that 8 up to a 9. So the answer there would be 1.099. The last thing I want to show you is something new to the yellow calculators on the software. So if you have older software, your calculator won't be able to do this, but there is a way to upgrade your calculator. So come see me, Mrs. Irwin, or your teacher to find out how you can get your software upgraded. So I want you to notice keystrokes here. If you hit the alpha key, and that's not going to work, is it? Let's try this. You hit the alpha key, and then you hit the F2 key, this will pop up right here. And if you notice down here, it says log base with a parenthesis. And if I choose that one right there, what's going to come up on my calculator is something like this. Log, and I can type in my base 3 and my 15. And so I can evaluate this also, and I see that that would, again, I'm going to look at the fourth decimal, that's a 9, so this 4 is going to bump up to a 5. So I'm going to get 2.465.